So this is another lecture of vectors. We are taking exercise 5.1 from the textbook, and this is Maharashtra State Board textbook. State Board textbook, exercise 5.1. The earlier lectures, I have given you the concepts on basics of vectors. That is definition of vector, types of vectors, then collinear vector, scalar multiple of a vector, then algebra of vectors, that is triangle law of vector addition, parallelogram law of vector addition, polygon law of vector addition. I have also taught you the position vector of a point. All these points we have covered till last lecture. Now in this lecture, we have solved some problems also on 5.1. Some more problems are now being taken. See, question number 1. The vector A bar is directed due north. They give you the direction of vector A bar. It is due north. That is in the direction, north direction. The magnitude of A bar they give, that is 24. The vector B bar is directed due west. Direction of vector B bar is in west. They give you the mod of B bar, that is magnitude of vector B bar. They want you to find vector mod of vector A bar plus B bar. You have to find the magnitude of A bar plus B bar. Okay. Now here what is important, see, we should have the sense of direction. We should have the sense of direction on a paper. How do we take direction? See, on a paper, we will always take direction like this, you know, see, this is, we take this as north, this is south. Then on the left side, this is west. The left is west and the right is east. This is east, this is west. Okay. North, south, up, north, down, south. Left, west, and right is east. Right is east. Okay. Left is west. Left is west. Okay. So you can have 4 letters. Left, 1, 2, 3, 4. West, 1, 2, 3, 4. Left is west and the right is east. Right is east. This is just a way of remembering. Left, west. Now here they say vector A bar. What is vector A bar? Vector A bar is due north. So here I make vector A bar, which is in the north direction. And how much is the magnitude of this vector? They say the magnitude of the vector is 24. So we have vector B A bar, which is 24 units. Now when they say magnitude of the vector, remember what is meaning of magnitude of a vector? The magnitude of the vector is the measure of the length that you are using to show the vector. Magnitude of a vector is the measure of the length. So it starts from here till here. See, this length which you measure is 24. This length is 24 units. You got it? So you have vector A bar due north. Then you have another vector which is B bar, that is due west, and its magnitude is 7. Okay, its magnitude is 7. So here I take 7. Right, this is 7 units. Definitely vector B bar is smaller than vector A bar, so this is 7 units. So from here to here, it is 7 units. Now what do they want? They want the magnitude of A bar plus B bar. Now in order to get magnitude of A bar plus B bar, what will you have to do first? You will have to find A bar plus B bar. So you want magnitude of A bar plus B bar. You want A bar plus B bar and then you want magnitude, right? So if you want the magnitude of A bar plus B bar, first you will have to find vector B bar. Okay, sorry, vector A bar plus B bar. So see, for that what I do, I will use the concept of free vectors, and this vector b bar I shift this way. See, I'm using the concept of free vectors. So what I did, I shifted vector b bar here. That is where a bar ends. Okay, the terminal point of a bar, I coincide with the initial point of b bar. Okay, then what I want the resultant. I want the resultant. Now a bar plus b bar is the sum of vector a bar and b bar. So where the vector a bar ends, from there b bar starts. So a bar is this plus b bar. You getting it? So this is a bar plus b bar. I'm going to use the triangle law of vector addition. See, what is a bar plus b bar? That is this point to this point is a bar, and then from here to here is b bar. You got it? So I got here a bar plus b bar. This vector here is a bar plus b bar. I got here a bar plus b bar. I want the magnitude of a bar plus b bar. Now see, in order to find the magnitude of a bar plus b bar, I will have to find the length of this segment, you know, the one which is representing a bar plus b bar. So this big is a bar plus b bar. I'll have to find the length. Now what I noticed that this angle is 90-degree angle. Why? Because see, the direction here, north direction and west direction, the angle is 90 degrees. So here we have 90-degree. Now the length here I know the lengths of these two perpendicular sides. Mod of a bar is 24. That gives me this side as 24, this side as 7. Okay. Now I will use the Pythagoras theorem. What I do is, let me name here AB. Okay, wait. I will write this as O, this as A, and this as B. So in triangle, now I will write in triangle OAB by Pythagoras theorem, So what do you have now? By Pythagoras theorem, you will have OB square. In fact, actually, you know, you don't have to write OB bar, because if you write OB bar, you'll have to write mod of that. Right now, we are applying the theorem, so we are actually taking only the length into account. So OB bar square is AB bar square plus OA bar square. So we get here AB bar square is 7 square plus OA square is 24 square. So this is 49 plus 576. Okay. So how much is OB square? So we get therefore OB square equals to 625. So we got OB as square root of 625. What we get? We get here OB as square root of 625. So OB equals to 25. We got, okay. Now this OB which you got as 25 is nothing but the this is nothing but the mod of a bar plus b bar. So you finally got therefore mod of a bar plus b bar is equal to 25. See, very simple question. Okay, I hope you followed it. Please copy. So now here we have the second question. It reads as, you know, in the triangle PQR, PQ bar is 2a bar. PQ bar is 2a bar. PR bar is 2b bar. So you have the triangle PQR. PQ bar is 2a bar. See this vector PQ bar. I drew the triangle PQR. Then I'm showing the vector PQ bar as 2a bar. Then QR bar is 2b bar. The midpoint of PR bar is M. Okay. So here you have the midpoint, which is M, and midpoint of this is M. They say find following vectors in terms of A bar and B bar. We have to find the following vectors, that is PR bar. We have to find vector PR bar in terms of A bar and B bar. We have to find vector PM bar. PM bar is this vector. This vector is PM bar. See, M is the midpoint of PR. M is midpoint of PR, this midpoint of PR. So PM is 1 by 2 PR, and hence PM bar will be 1 by 2 times PR bar. And then we also have to find the vector QM bar. Look at this QM bar here. Okay. So let's begin. See, first of all, I'll go for PR bar. I will write in triangle. I write in triangle PQR by triangle law of vector addition. Triangle law of vector addition. So see, what do I get? I get, now I apply triangle law of vector addition. So see, PQ bar plus QR bar. PQ bar plus QR bar. P to Q, Q to R is same as P to R, PR bar. Got that? So here we will have, I will write here, therefore, PQ bar plus QR bar equals to PR bar. Okay. What is most important in triangle law of vector addition, that the terminal point of one vector, see Q, PQ bar, Q, will be the initial point of another vector, see Q, PQ, Q here, QR, Q here. You understand? So the triangle law of vector addition gives us PQ bar plus QR bar as PR bar, PR bar. Okay. Now PQ bar is 2A bar plus QR bar is 2B bar. So you have PR bar as, so you can write therefore PR bar as 2 is common, A bar plus B bar. Okay, this is the first one. Now I have to go for PM bar. See, vector PM is 1 upon 2 times vector PR. Okay, PM is half of PR. I will write PM bar is 1 upon 2 times PR bar. Now PR bar, you just calculate, you found PR bar just now. So here what you will get? You will get here, therefore, I will get here, therefore PM bar equals to PM bar equals to 1 upon 2 PR bar. What is PR bar? It is this. So 1 upon 2 of this will be 2 will cancel. So you'll have A bar plus B bar. See, this is PM bar. Okay. You got this. This is number 2. After this, which one you want? You want QM bar. See, for QM bar, what I will do? I shall apply the triangle law of vector addition in this triangle. Which triangle? PQM. See, I will apply in the triangle PQM. I will apply that in the triangle PQM. This triangle I will apply the triangle law of vector addition. Okay. So I will write in triangle PQM by triangle law of vector addition. See what I get. See, I apply. So I write here PQ bar plus qm bar, pq bar plus qm bar equals to pm bar, equals to pm bar. So what will be qm bar? Therefore, qm bar is pm bar minus pq bar. pm bar minus pq bar. So you got qm bar as cpm bar, that is a bar plus b bar minus pq bar. pq bar is 2a bar. 2a bar. Got that? So therefore you have qm bar as b bar minus a bar. We got the third one as well. We got the third one as well. I hope you all followed this. Please copy it. Okay, before we go for the next question, I would like to give you here an introduction to a regular hexagon. I want you all to understand the concept of regular hexagon. So let me first draw one regular hexagon for you. I will draw a regular hexagon. Definitely it is not by scale, so the regular hexagon which I am drawing is not by scale. So it might have some error, but then I will try to draw one which is almost a regular hexagon, almost. I will try to draw one which is almost a regular hexagon. So here we have a regular hexagon, and the name of this regular hexagon I will keep A, B, C, D, E, and F. See, this is still not the perfect regular hexagon, but let us consider this to be one. Now I join this way. See, if I had a perfect regular hexagon, then this point would have been a single point. We have A, B, C, D, E, F as a regular hexagon. A, B, C, D, E, F is a regular hexagon. Now in this, you check AD, AD, then BE, BE and CF are diagonals. What are they? They are diagonals of regular hexagon. See, when we say regular hexagon, try to understand that all the sides are equal. Why do we call this as a regular hexagon? Because we take all the sides are equal to each other. See, AB is equal to BC equals to CD equals to ED equals to EF equals to AF. Okay. All sides are equal. That's why it is known as regular hexagon. Okay. Now these are diagonals. AD, BE, and CF are diagonals. So you have three diagonals: AD, BE, and CF. What is more important? These diagonals are concurrent. Okay, the diagonals of regular hexagon are concurrent. What does that mean? It means that these diagonals intersect each other at a single point. At this point, this is one single point. These diagonals are concurrent. Okay. Moreover, see, this BC is parallel to EF. You check this. The opposite sides of a regular hexagon are parallel. The opposite sides of a regular hexagon are parallel. The opposite sides of a regular hexagon are parallel to each other. They are parallel to each other. So see, BC bar is parallel to FE bar. AB bar is parallel to ED bar. You check this AD bar, this side. AD bar is parallel to ED bar. It's all happening because of this being a regular hexagon, a regular polygon. One more thing. Now check this out. Look at the quadrilateral. Look at the quadrilateral. Okay, before that, I will name this as, say, let me name this as P. The center, I'm naming it as P. Look at the quadrilateral. The quadrilateral PBCD. The quadrilateral PBCD is a rhombus. What is it? It's a rhombus. Why it is a rhombus? Or it's a parallelogram. You can say post parallelogram. Okay, before that, one more point I would like to write. See, you take any of the diagonal, it will be double the length of side of the hexagon. Okay, so first of all, as you know, it's a regular hexagon. So this being a regular hexagon, what you have AB equals to BC equals to CD equals to ED equals to AF. Okay, I'm writing the magnitude. I'm not taking the vector. Okay, so I'm writing the magnitude. See, I have not put anywhere, I haven't put bar. Okay, I'm right now taking only the magnitude. So AB, BC, CD, ED equals to EF, also EF. See, these all sides are equal to each other. Okay. Now, what is more important here is you take any of the diagonal, it is a double. The diagonal is double the side of the hexagon. Like AD, length of AD is 2 times of any of the side. AD is 2 times of AD is 2 times of BC. See, once again, I am taking the magnitude. So, as such, AD is 2 times of AB, AD is 2 times of BC. You can write any of the side. Remember, any of this, any of this diagonal, any of this diagonal is 2 times the side. So, this diagonal is double of side, any of the side. Or for that matter, this diagonal is also double of any of the side, or this diagonal is also double of any of the sides. So all the diagonals are double of the sides. Okay, so here I can write the length of, I can write here, the length of diagonal, length of diagonal of a regular hexagon is twice, that is 2 times, twice the side of regular hexagon. Okay, so yeah, here we wrote the opposite sides of a regular hexagon are parallel to each other. Okay, just before that we wrote the diagonals of a regular hexagon are concurrent. These diagonals are concurrent, you know. The point where they meet is the center of the regular hexagon. So that point also I will note it. I will note that point here. Okay, the point of intersection, the point of intersection, point of intersection of these diagonals is the center of, it is the center of regular hexagon. Okay, I will write it separately because so what the point is, the point is, I write it here. The point of intersection, the point of intersection of diagonals is the center of the, is the center, it is the center of regular hexagon. It is the center of regular hexagon. So this P, here P is the center of the regular hexagon. It is the center. Center divides the diagonal into equal parts. The center P will divide the diagonal in 2 equal parts. So what you will have? You will have AP equals to PD. You will have BP equals to EP and FP equals to CP. You understand? And just before this, you have written that the length of diagonal of a regular hexagon is twice the side of regular hexagon. So see here. If I have AD, if I have A to D as double, if I have A to D as double of B to C, and then I have AP as half of AD, what does that mean? It means that AP is equal to BC. What does it mean? This AP and BC are equal. It means that AP and BC are equal. So that will make this as a rhombus. See this, that will make these quadrilaterals as rhombus. See, this is one rhombus you have here. You have a rhombus here. Check this. This is one of the rhombus. Then you have another rhombus here. See, this is another rhombus. Then you have another rhombus as this. You have this as another rhombus. So ABCP, PBCD, FPDE, AFEP, these all are rhombus. Okay, I can write that also here. I can write here. I can write here. ABCP, PBCD, then FPDE, FPDE, APEF, APEF are rhombus inside the regular hexagon. Okay, you can check this out. You can copy this. See, these are certain points which will help us solve some problems. Okay, so before I start with the problem, I wanted to give you this idea. You can once again repeat this. See, I will repeat this for you before. I will repeat this for you once again. So here we wrote. See, ABCD is a regular hexagon. Now you know if it is a regular hexagon, then all the sides are equal. AB, BC, CD, ED. Okay, we wrote this. Then these are the diagonals. Just now we saw what are they? They are diagonals. These are all diagonals. Okay, AD, BE, and CF. They are all diagonals. Then the diagonals are concurrent. All the diagonals will intersect each other at one point. Then the point of intersection of these diagonals is the center of hexagon. This point P is the center of the hexagon. Okay. Then the opposite sides of a regular hexagon are parallel. See, opposite sides. So this AF is opposite to CD. They are parallel. Then we have AB, which is AB, which is opposite to ED. They are parallel. And we have EF, which is parallel to BC. Okay, EF or FE, whatever you say. So the opposite sides are parallel. We saw that. Then all the sides are equal. Then we saw that length of any of these diagonal is double the side of the regular hexagon. And then I showed you some of the rhombus. Okay, you can copy this. So now we have a problem based on, which is based on the regular hexagon. It says OABCDE is a regular hexagon. The points A and B have position vectors and A bar and B bar respectively refer to the origin O. Okay. So what is the name of the regular hexagon? It is OABCDE. So here I take O. So this is OABC. This point is C. Okay. Let me use another color. So here I have O, A, B, C, then D. This is D and E. Okay, this is regular hexagon. They say points A and B have position vector as A bar and B bar respectively. They give us the position vector of these points A and B. The position vector of point A and B, they say the position vectors they say as A bar and B bar respectively referred to the origin O. So the position vector which they give is referred to the origin O. So it means this point O here happens to be the origin. So they give you OA bar as A bar. Okay, this is A bar they give, and they give OB bar as B bar. The point to be noted here that the position vector of point A and B which they give, it is with respect to O. The position vector of point A and B which they give as A bar and B bar, it is with respect to referred to the origin O. So this one point, one vertex of the regular hexagon also happens to be the origin. Further, they say find in terms of A bar and B bar the position vectors of C, D and E. We have to find the position vector of C, D and E. Okay, so I have to find position vector of C with respect to O. Then I have to find the position vector of D with respect to O and position vector of E with respect to O. So I have to find these vectors. Okay. To find OC bar, so I understand my solution. See, what is the solution? What is the question here? I understand the question. To find, see, to find OC bar, OD bar, and OE bar in terms of A bar and B bar. We have to find these vectors OC bar, OD bar, and OE bar in terms of A bar and B bar. Okay. So see, how do I go ahead? First of all, I will apply triangle law of vector addition in the triangle OAB. See, I will apply triangle law of vector addition in this triangle. Now, why I'm doing that, you will understand in a while, in a short while. So I write here in triangle OAB by triangle law of triangle law of vector addition. Okay, so see here what we have. So we have here OA bar, see OA bar plus AB bar, you understand, equals to OB bar, right? So I have here OA bar plus AB bar, this vector is AB bar, I showed the arrow here, plus AB bar equals to OB bar equals to OB bar. So what's AB bar? AB bar is OB bar minus OA bar. So AB bar I get, OB bar is B bar minus A bar. So I got AB bar. Okay. Now see, after I got AB bar, what can I say? Look at the diagonal, look at CD bar. Okay. I just explained you the regular hexagon in detail. Look at CD bar. The length of CD bar, CD being a diagonal, the length of CD bar will be 2 times of AB bar. The length of CD bar is 2 times of AB bar. Moreover, CD, I'm sorry, it's OC bar. Okay, I'm extremely sorry. I said CD bar. CD bar is this vector. It's actually OC bar. Look at this. I want OC bar. I want OC bar, which is the position vector of point C. Okay. What have they said? What the question was? The question was to find position vector of C, D, and E. So position vector of point C is nothing but OC bar. You understand? This is the position vector of point C. So what I noticed that this vector OC bar is having the length equal to the diagonal of the hexagon. So OC bar has length 2 times of AB bar, and it is also parallel to AB bar. Okay, it is parallel to AB bar. So what I notice here, I notice that direction of OC bar is same as AB bar. Okay, so I will write OC bar is equal to 2 times of AB bar. Okay, see, OC bar is parallel to AB bar and it is twice. OC bar has the same direction as AB bar and it has magnitude 2 times. We have already written this. The diagonal length of any regular hexagon is 2 times the length of the side. So OC bar is 2 times of AB bar. So what is OC bar? OC bar is 2 times B bar minus A bar. Okay, and remember students, OC bar is the position vector of point C with respect to O. So you got therefore C bar equals to 2 times B bar minus A bar. You got 2 times B bar minus A bar. This is number 2. Now, after this, I will go for the triangle. I will apply the triangle law of vector addition in triangle OBC. See, I will go for triangle OBC. This triangle I will go for. Okay. So I write here in triangle OBC by triangle law of vector addition. So see, what do I get? I get here OB bar, check the triangle OBC, OB bar plus BC bar is equal to OC bar. You check, OB bar plus BC bar is equal to OC bar. Yes. OB bar plus BC bar equals to OC bar. OB bar is B bar that we are given. BC bar we will find, and OC bar is just now we found. What is OC bar? OC bar, which is C bar. Okay, OC bar is C bar. So I'll have here BC bar is equal to, I will have here BC bar is equal to C bar minus B bar, and this C bar we will substitute from here. So we will have BC bar equals to 2 times B bar minus A bar minus B bar. So we have 2B bar minus 2A bar minus B bar. So this gives us B bar minus 2A bar. This is BC bar. Okay, but then this BC bar isn't the required question. See, don't worry. We got BC bar. We got BC bar. This vector we got BC bar. What I'll do next, I know that opposite sides in a regular hexagon are parallel. So see, BC bar is parallel to OE bar. BC bar is parallel to OE bar. Look at the vector OE bar. This is BC bar and here you have OE bar. So they are parallel and they are also equal in length. So what will happen? We will be now writing OE bar, vector OE bar equals to vector OE bar equals to vector BC bar. Got that? So here I have vector, I have here we know that vector OE bar equals to BC bar. Therefore, OE bar is nothing but position vector of point E, which is E bar. So E bar is BC bar, B bar minus 2A bar. So this is our third that we found. Okay, we got E bar. Next. So I got position vector of point C and this position vector of point E. I want now position vector of point D. So what I will do? I shall now be finding I will apply the triangle law of vector addition in, I will apply the triangle law of vector addition in this triangle ODE. Which triangle? Triangle ODE. I will apply the triangle law of vector addition. So here what I will write? I will write OD bar plus DE bar equals to OD bar plus DE bar equals to OE bar. Okay, I'll explain this. See, what am I going to do? Check. See, from point O, I go to D. So this is OD bar. Then from point D, I move to E. This is DE bar. So OD bar plus DE bar is same as point O to E. Okay. So via D, when you move from O to E via D, it is OD plus DE. And when you go directly, it is OE. Okay. This is triangle law of vector addition. I will apply. So I write here in triangle ODE, in triangle ODE by triangle law of vector addition. So see what you get. You have here OD bar plus DE bar equals to OE bar. OD bar plus DE bar equals to OE bar. See, what will be OD bar? Therefore, you have OD bar, which is your aim. OD bar is OE bar, which is E bar minus DE bar See, what shall I do here? I'll write here, therefore, OD bar, which is a D bar, equals to E bar. E bar I have already found. E bar is B bar minus 2A bar. So this is B bar minus 2A bar minus DE bar. Look at the vector DE bar. Vector DE bar is equal to vector BA bar. You check this. The direction of these two vectors are opposite to each other and their magnitude are equal. See, the vector DE bar is in this direction. Are you getting? And I have found vector AB bar which is in this direction. So AB bar and DE bar are opposite to each other. Is that clear? And they are equal in length because they are the sides of hexagon. The length is definitely equal. See, AB bar and DE bar, they have the same length, but their direction are different. So what would I do? See, I will write here. DE bar is equal to BA bar. I will write. Let me write this as. Okay, so E bar minus DE bar, which is minus, and DE bar, D to E is same as B to A. Okay, so minus BA bar. So I have B bar minus 2A bar minus BA bar. What I will do, BA bar is nothing but minus AB bar. Okay. See, once again I repeat, DE bar is same as BA bar. But BA bar is negative of AB bar. Okay. So here I have negative of AB bar, and this AB bar we have calculated. So this is B bar minus 2A bar plus AB bar, which is B bar minus 2A bar plus, what is AB bar? AB bar is B bar minus A bar. B bar minus A bar. So I have therefore D bar equals to 2B bar minus 3A bar. And this completes the final answer. This is number 4. Okay. We have found the position vector of point E, point D, and point C. We have found all the three. I hope you followed it. Just copy this.